Obliterated. It is one of Iran's costliest and longest-running military projects, roughly a 40-year, multi-billion-dollar effort. The public justification is purely defensive, a shield for the nation, but the scale of the arsenal tells a different story. With over 3,000 ballistic missiles, it is the largest inventory in the Middle East. This is not a force built merely for deterrence. It is an unthinkable arsenal of offensive capacity hidden across the country. But to understand how this offensive force was conceived, we must go back to its painful birth. The genesis of Iran's missile strategy lies in the brutal trench warfare of the 1980s conflict with Iraq. Facing Saddam Hussein's overwhelming air power and superior army, Iran found itself desperate. It had no air force to speak of, and its ground assaults were proving futile. The turning point came with what became known as the War of the Cities. Beginning in 1985, Iraq began launching modified Scud missiles into Iranian urban centers, terrorizing civilians in Tehran and beyond. Iran had almost no way to respond in kind. This vulnerability, this feeling of being bombarded with impunity, was a national trauma. In that crucible of desperation, the imperative was forged. Iran would develop its own long-range strike capability, no matter the cost. It was not about deterrence at that moment. It was about sheer survival and the need to retaliate. They acquired a handful of Scuds from Libya and North Korea, reverse-engineered them, and began their own frantic program. Missile strikes on Tehran hardened public resolve in many accounts. This was the seed, planted in the soil of wartime necessity and watered with the blood of civilian casualties. The scattered, hidden arsenal of today was born from the concentrated terror of those attacks. The strategy of dispersal began here, as a lesson learned from having nowhere to hide. That lesson came at a staggering price. Over 4 decades, Iran poured tens of billions of dollars into its missile program, by some estimates roughly 30 to 50 billion, making it the single largest sustained military investment in the country's modern history. This was not optional spending. It was the cost of sovereignty, paid in defiance of relentless international sanctions that choked off access to foreign technology, spare parts, and expertise. From the 1980s onward, many missile fielding efforts became a fight for self-sufficiency. Early on, the regime acquired a handful of Soviet-designed Scud-Bs from Libya and North Korea, but sanctions soon slammed most legal doors shut. So Iran turned inward. The Defense Industries Organization and the Aerospace Industries Organization were tasked with reverse engineering, then innovating. The Shahid Hemmat industrial group became the beating heart of liquid-fueled missile production. Thousands of scientists, engineers, and technicians were recruited, trained, and shielded from brain drain by state-funded universities and secretive research hubs. The financial drain was immense, but the goal was non-negotiable: a wholly indigenous production line. By the mid-2000s, Iran was manufacturing its own solid propellant motors for the Sigil missile, a feat that required mastering complex chemistry and precision casting. The sprawling underground cities carved into the Zagros mountains alone cost billions to excavate and harden, yet the payoff was a supply chain immune to embargo. Missiles such as the Shahab 3 and Ghadar became symbols of self-reliance, a declaration that the country would never again be defenseless, no matter the economic burden. But self-reliance means little if the weapons can be destroyed before they are ever used. So Iran built its missile force around a single, uncompromising principle: survivability. The goal was not just to have missiles, but to ensure they could survive a massive first strike and fire back. This doctrine goes back to the 1980s, when Iraqi air raids targeted Iranian cities and infrastructure. The lesson was stark: any fixed, visible asset is a target, so they began digging. Today, the architecture of survival rests on 3 pillars: hardened bunkers, mobile launchers, and deeply buried tunnel complexes. The numbers alone tell the story. Across the country, roughly 24 missile bases are scattered, many inside mountain ranges like the Zagros and Alborz. Some sites are simple garages for transporter-erector-launchers, or TELs, which constantly move on civilian roads. Others are vast underground cities carved into solid rock, with blast doors, internal roads, and ventilation shafts reaching hundreds of meters deep. Satellite imagery has revealed sites like the Imam Ali base, a subterranean complex with multiple entry and exit portals, making targeting extremely difficult. The logic is simple. A single enemy bomber or ballistic missile can destroy a known factory or launch pad, but a TEL hidden in a mountain tunnel, or moving at night, forces the attacker to find and hit hundreds of fleeting targets almost simultaneously, an enormously complex challenge. This dispersal is layered. Command centers are separate from launch sites. Fuel and warhead storage is decentralized. Even within a single tunnel complex, missiles are parked in separate chambers to limit damage from a direct hit. Some of these facilities are also defended by overlapping air defense systems, adding yet another layer of difficulty. The bedrock itself becomes armor. Some tunnel entrances are cut deep into granite, providing natural overhead cover of up to half a kilometer. The cost is staggering, likely running into tens of billions of dollars over 4 decades, but the result is an arsenal that can absorb a tremendous blow and still respond. It is an architecture born of paranoia and necessity, a bet that geography and concrete can offset technological inferiority. The missile force might not be invisible, but it is designed to be nearly indestructible, a silent, buried fist waiting to emerge. But the true strength of this strategy lies in the land itself. The Zagros mountain range, a 1,000-mile spine of rugged peaks and deep valleys, became the program's ultimate fortress. This is not a landscape that welcomes invaders. Its terrain is a natural labyrinth, perfect for concealment. Here, geography was weaponized. Engineers and military planners looked at these ancient rock faces and saw opportunity. They carved directly into the mountains, creating networks of tunnels wide enough for mobile launchers to move and hide. They constructed deep underground facilities, some referred to as missile cities, where entire brigades could operate from within the earth. The locations of these sites are a closely guarded secret, but intelligence analysts suggest there are dozens, perhaps hundreds, of such hardened positions scattered throughout the range. The rock provides a shield against surveillance and a formidable barrier against attack, with hundreds of feet of solid stone offering protection that no man-made bunker could easily match. In some cases, access roads are limited and easily defended, turning each hidden complex into a nearly autonomous citadel. The Zagros does not just hide the missiles, it absorbs them, making the mountains and the weapons one and the same. This fusion of firepower and geology may have created a deterrent not just about the missiles, but about the difficulty of ever finding them all. But this hidden arsenal was only one part of a much larger puzzle, according to some analysts. To truly become invulnerable, the missiles also had to move. This is the role of the transporter-erector-launchers, or TELs. These massive vehicles are the mobile shield of Iran's missile force. Roughly half of Iran's ballistic missiles are estimated to be assigned to these road-mobile units. Each TEL is a complete launch system on wheels, capable of carrying a missile hundreds of miles, raising it to a vertical position, and firing it within minutes. Their greatest defense is unpredictability. They operate from a vast network of pre-surveyed launch points scattered across the country, from deserts to forests. More critically, they are hidden within an extensive system of mountain tunnels and camouflaged garages. A TEL can emerge from a hidden portal in the Zagros, drive to a launch site, fire, and disappear back into the mountain before its launch plume has even cleared. This makes them nearly impossible to track in real time. The strategy creates a relentless game of cat and mouse for any adversary. You cannot destroy what you cannot find. Even if you locate one launcher, dozens of others remain hidden and ready. This constant movement and concealment means the mobile missile force is never static, never presents a single target, and can retaliate from almost anywhere. The mountains may store weapons and launch them, but the specifics are unclear. From the early days of its program, Iran's missile technology had a simple, identifiable ancestor, the Soviet-designed Scud. These liquid-fueled road-mobile missiles were the starting point, reverse-engineered and produced domestically as the Shahab series. They provided a foundational, though limited, strike capability, with ranges of a few hundred kilometers and notoriously poor accuracy, often measured in circular error probabilities of hundreds of meters. But this family tree grew and branched out dramatically. Engineers moved from modifying imported designs to developing indigenous families. The liquid-fueled Ghadar and Imad missiles introduced improved guidance and longer ranges, pushing towards 1,600 kilometers. The real evolutionary leap, however, came with solid fuel technology. Solid propellant allows for faster launch preparation, greater reliability, and safer storage. This shift birthed the SIGINT and later the dispersal families, with ranges extending to roughly 2,000 kilometers. These missiles are more agile and can be launched on shorter notice from their hidden mountain bases. The latest branches of this arsenal focus on precision. New guidance systems, including likely satellite navigation and terminal homing, aim to transform these weapons from area terror devices into tools for striking specific military targets. From crude Scud derivatives, Iran has cultivated a diverse and deeply rooted missile forest, with each new generation representing a step toward greater range, survivability, and intended accuracy. But this capability is not confined to Iran's soil. It forms the very core of its strategic doctrine. The ballistic missile program is the ultimate force multiplier for Iran's network of regional allies, a project often called the Axis of Resistance. By sharing missile technology and complete systems with groups like Hezbollah in Lebanon, the Houthis in Yemen, and various militias in Iraq and Syria, Iran effectively extends its own strategic reach by thousands of miles. It creates a formidable and dispersed deterrent, a ring of fire far beyond its own borders. These proxies can hold adversaries at risk, forcing them to allocate vast resources for missile defense and complicating any potential military planning against Iran itself. In many instances, a proxy's missile may respond to perceived threats instead of an Iranian soldier. This could turn conflicts in the region into potential multi-front engagements for Iran's rivals. The missiles provide what Tehran calls strategic depth, making its allies into forward operating bases and early warning systems. It is a cost-effective strategy, projecting immense power and creating persistent leverage without the political risk of direct confrontation. For a nation whose conventional air force and navy are relatively limited, these shared missiles are the great equalizer, ensuring that even from hidden sites in Yemen or Lebanon, the long arm of Iranian deterrence can be felt. This long arm of deterrence does not simply materialize from the shadows. It is forged and sustained by a sprawling industrial web inside Iran. This network is not a single, vulnerable factory, but a deeply buried ecosystem of roughly 100 production, research, and testing facilities. The program is managed by the Islamic Revolutionary Guard Corps Aerospace Force, but it draws on a vast supply chain of state-owned defense conglomerates, university spin-offs, and front companies. The Aerospace Industries Organization, for example, coordinates a family of entities like the Shahid Hemmat Industrial Group, which builds liquid fuel engines, and the Shahid Bakheri Industrial Group, which produces solid fuel motors. At sites like Parchin and Kojir, technicians cast large-diameter rocket casings and mix volatile composite propellants in hardened buildings. The missiles themselves, from the short-range Fateh to the medium-range Emad and the solid-fuel Segil, are designed and constantly upgraded in-house. Don't be afraid to go out on a limb. That's where the fruit is. Originally reverse-engineered from foreign imports, now includes ring laser gyroscopes and satellite navigation receivers, making the weapons less dependent on outside support. This industrial web extends into seemingly civilian workshops and metal foundries, making it extraordinarily difficult to isolate. A precision strike on one plant will not stop supply, because duplicate lines exist elsewhere, often inside mountain tunnels. Roughly 20% of the program's workforce may be dedicated to research, focusing on new materials and warheads. This homegrown capacity ensures that even if missile stocks are drawn down, they can be replenished from within, rendering the system resilient to both combat losses and international sanctions. The industrial web is the quiet, humming heart of the missile program, making the arsenal an organic, self-healing entity rather than a simple stockpile. This self-healing arsenal is also a loudspeaker. Iran may choose when its missiles appear, and each appearance could serve as a message. A launch is rarely just a technical test. It can be scheduled days before a round of nuclear negotiations, or hours after a sanctions vote, with state television narrating the event in patriotic terms. Missiles are named and displayed to compress 4 decades of grievance into a single image. Khorramshah, the city retaken from Iraq in 1982, becomes a missile. Qiyam, meaning uprising, becomes another. These names turn industrial products into national memory. Underground missile cities, filmed in slow tracking shots through tunnels lined with launchers, announce that the arsenal cannot be found and destroyed in one strike. In 2017, when Iran fired ballistic missiles at what it called terrorist targets in Syria, the footage served two audiences at once. To regional rivals, it demonstrated range and precision. To the domestic public, it showed that locally built weapons could strike far from Iran's borders. Military parades put missiles on truck beds beneath banners denouncing the United States and Israel, turning the program into a theater of defiance. Successful tests are replayed for days, and even mixed results can be edited into a victory. This is the calculated message. According to some analysts, the missile is never merely a weapon. It is a statement that Iran can absorb pressure, rebuild what is broken, and reach its enemies without asking permission. For any adversary, this network presents a brutal mathematical problem. Iran's missile force is not concentrated in a few bases that can be crippled in a single night of airstrikes. It is scattered across hundreds of sites, many buried deep inside mountains in the Zagros range. Hardened bunkers with reinforced concrete and steel blast doors protect the missiles and their crews. According to some reports, mobile launchers may shift positions along hidden road networks, emerging only to fire. A strike planner must ask, how many aim points can we realistically hit in the first wave? Even a massive air campaign would struggle to destroy more than a fraction of the total force. The rest would survive and launch within minutes. That is the core dilemma. You cannot guarantee a disarming first strike. Instead, you risk triggering the very barrage you hope to prevent. Intelligence gaps make this worse. Iran has spent decades perfecting deception. Tunnel entrances are camouflaged. Decoy sites are built alongside real ones. Underground missile cities, like the one revealed near the Gulf Coast, stretch for kilometers with multiple exits. Destroying one entrance does not disable the entire complex. The weapons are designed to ride out an attack and strike back. So any decision to strike becomes a gamble with catastrophic consequences, not a clean military solution. But that imposing image of invulnerability hides a more fragile reality. At the heart of the program lies a persistent accuracy problem. Iran's older liquid-fueled missiles, like the Shahab 3, have a circular error probable of hundreds of meters. They can hit a city, but not a specific building. Even the more advanced solid-fueled Fateh family, while far more precise, relies on guidance systems that are almost impossible to source domestically. Key components, ring laser gyroscopes, accelerometers, and specialty alloys for airframes, were historically imported. Under sanctions, the supply chain is a patchwork of smuggling, reverse engineering, and unreliable substitutes. This dependence means production rates can stall, and quality control suffers. Then there is the command and control dilemma. The dispersed network of bunkers and mobile launchers looks resilient, but it depends on a centralized, top-down launch authority. Orders flow from Tehran through a fragile chain of fiber optic cables and microwave relays. In a conflict, those nodes could be targeted early, severing the link between the leadership and the missile crews hiding in mountain tunnels. Each launcher might survive physically, but without a valid launch order, it becomes a stranded asset. The system is built to absorb a first strike, but its brain remains a single point of failure. So, does this vast and dispersed system achieve its ultimate goal of being an indestructible deterrent? In many crucial ways, the answer is yes. The sheer scale, the geography, and the decades of investment have likely created a force that is, for all practical purposes, extremely difficult to eliminate in one comprehensive attack. This survivability grants Iran a powerful card to play, a guaranteed means of retaliation that makes any adversary think twice. It is the bedrock of their defense strategy. However, true strategic stability requires more than just surviving the first blow. It requires a reliable command. And here, we find the system's critical vulnerability. It is often said that a network is only as strong as its most fragile node. While the missiles and launchers are scattered, the senior leadership and the communication links needed to order a launch are not nearly as numerous or as hardened. In a crisis, these could be targeted. As one analyst put it, the body is dispersed, but the brain remains concentrated. Each hidden launcher might physically survive an initial strike, but without a valid, authenticated launch order, it becomes a stranded asset, a weapon without a will. Therefore, the program creates a paradoxical and perilous standoff. It deters through the promise of a painful retaliation, but it also incentivizes any potential attacker to consider a devastating, decapitating first strike against Iran's command structure in the opening moments of a conflict. This introduces a dangerous element of instability. In seeking an indestructible deterrent, Iran may have built a system that makes the trigger fingers on all sides more nervous, locked in a cycle where the greatest fear is not of the missiles that are seen, but of the order that might be lost.